It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 7, which in your book happens to be lesson 6 just because it's an older copy. So this is lesson 6/7, whatever we want to call it, but it's the translating between English and algebra lesson. So in this lesson, we're going to be making connections between how we can go from math to words and words to math. So let's get started here. So we've got a quick little opening exercise reviewing our formulas rearranging. So pause the video right now and try this opening exercise. So Michael's got this formula here, and we want to find R. We want to find R, I equals PRT, and we want to get R by itself there. Well, hopefully you notice that there's only multiplication occurring, which means the only thing that I can really do is divide. So I got I over PT equals R. That's it. That's all we had to do for that problem there. So let's get to it. Let's get to translating here. So I want you to write me a calculation and a result that represents a number that is 5 greater than 3. So 5 greater than 3. So notice I'm starting with 3, and greater than seems like an addition operation. So this looks like 3 plus 5. I'm at 3, and I want 5 more than that. Write a calculation for a result that represents a number that is 2 less than 9. Well, notice, where am I starting again? I'm starting at 9, and I want to be 2 less than that, so 9 minus 2. I need your little warning lights to be going off here whenever you see less than. For greater than, more than, if you write 5 plus 3, it's fine. You cannot write 9 minus 2, as tempting as that is. Whenever you see these less thans, and even greater thans, more thans, you always start with that second piece, and because that's where you're starting. In English, we're 2 less than 9. 9 is where we're starting. Write a calculation and a result that represents the sum, well, sum means add, of -3 and 8. Find the sum. Add them together. Not bad. Write a calculation and a result that represents the difference. Difference is a subtraction operator, so 20 minus 12. Nothing crazy there with moving things around. Difference is normal. It's the less than. Warning that you need to deal with. Less than is the thing that's going to trick us for the next week or so. So please keep your eyes focused on finding less than words. If x represents a number, write an expression for a number 10 greater than x. So again, who am I greater than? I'm starting at x. X is the first thing I'm starting at, and I want to be 10 greater than that, so I'm going to add 10. If n represents a number, write an expression that represents 5 less than. Warning. We're starting with n. 5 less than this. So this is where I'm starting, and I want to be 5 less than it. N minus 5. Write an expression for a number that is 5 times greater, not 5 greater than, 5 times greater than. So this seems like multiplication. So I'm starting at 2, and I'm doing 5 times that, 2 times 5. Or I could write an expression for twice n. Well, twice, triple, quadruple, you should know what those words mean. Twice means 2 times n. And again, I'm not going to put a x or a dot or parentheses. To represent multiplication, we just don't put anything between the number and the variable. 2n is twice n. Write an expression for a number that is 3 more than twice the value of x. So more than twice the value of x is where I'm starting. Twice the value of x, and I want to be 3 more than that. So here's where I am now. I want to be 3 more than, so I'm going to add 3 to it. So hopefully you notice that this just takes time to read the problems and figure out what it's actually saying. Write an expression for 2 less than, warning, 1/3 of n. So I need 1/3 of n. That's where I'm starting, but I want to be less than. I want to be 2 less than that. So 1/3 of n minus 2. If x represents a number, write an expression for 3 times the sum. So notice here I'm finding 3 times the sum. Well, what's the sum? X plus 10. That's the sum. But I want 3 times that whole thing, so I can't just do that. I can't write 3x plus 10. I need to do 3 times this whole thing, 3 times the sum. So it's 3 times x plus 10. And for t here, if t represents a number, write an expression for 7 less than, all right, here we go. 7 less than 4 times the difference. Oh my goodness, 4 times the difference. 4 times what? The difference of t minus 5. That's 4 times the difference of t minus 5, but I need to be 7 less than that, so I'm going to subtract away 7. And hopefully your warning light went off there. So again, this just takes time to practice working through these words here. Consider a rectangle. There it is. I can consider it now. Whose length is 3 more than 5 times the width. So the length is 3 more than, so 5 times the width, and I want to be 3 more than that. So here's my width. What's the length? Well, the length is 5 times the width plus 3. Well, it's a rectangle, so all opposite sides are congruent, and there we go. Write an expression for the perimeter. Well, the perimeter is the total distance around the figure. So how many W's do I have? I have 1, 2, 3, 4, 5, 6, 7. I have 1 to 10 and 12 W's there. I'm going to add up all my W's. Plus 3 is 6. The perimeter is the sum of all the sides. Whereas the area of a rectangle is the product of the two sides, length times width. I'm going to find the product. Area is a product word, whereas perimeter is a sum. So I'm going to find the product of two sides, length times width. Area is length times width, so that's what I did. I did width times length, doesn't matter. The number of quarters that Dylan has in his pocket is, so quarters is 1 less than twice the number of dimes. So twice the number of dimes, but 1 less than that. Warning, warning, warning. Make sure you saw that less than there. So write in an expression for how much money he has. Well, he has Q quarters, but each of those quarters costs 25 cents. So the Q is how many. This turned it into how much money. Plus, well, how much are, nope, just kidding. Start again here. Actually, no, that's fine. 0.25 quarters plus how much are dimes? Dimes are 10 cents. 0.125 dimes. That's how much money he has in his pocket. 0.25 cents per quarter, 10 cents per dime. I can just make that substitution. 25 cents for every quarter. But instead of quarter, I'm going to write 2d minus 1 plus 0.10d. So 25 cents per quarter, 10 cents per dime. If I had pennies, it'd be 1 cent. If I had nickels, it'd be 5 cents, and so on. We could clean up this expression, but why would we? A garden that was originally a square, so I have a square, is adjusted so that one side is doubled while the other side is smaller by 3. So now I have this new garden here. So this is the original. Well, it's a square, so I'm going to call it x by x, x, x. Right? It's a square. All the sides are the same. But over here, I doubled this side. So how do I double something? Well, that's 2x. While the other side was decreased by 3. So it's this side, take away 3. The original side, take away 3. See if you can get me the perimeter and area like we did above. Pause the video and see if you can do that. So the perimeter, 1, 2, 3, 4, 5, 6 x's minus 6. I went around and I collected all the sides and added them together. While the area is the product, 2x times x minus 3. Hopefully you found this lesson not to be terrible. Again, it takes time to practice, and we're going to keep our warning lights looking out for the word less than. Warning, 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 warning. And I'll see you guys soon.